Hi, I'm Carrie Denver with the Huntington Stormwater Utility, and I'm here with Scott Kelly, the superintendent of the waste treatment plant. So Scott, what are some of the challenges you have at the waste treatment plant?
Some of the problems that we have here and the challenges are what we're dealing with is old antiquated equipment. So the oldest part of the plant was put online in 1964, and the newest part was in operations in 1986. So the age and continuous operation is just wear and tear over the years, and we're barely able to keep up with that. The first part of the process is our headworks. It's where the first part of cleaning and aeration of the plant, of the sewage when it enters the plant. In that we have bar screens that takes out large chunks. One of the problems we have are that we have very large bar screens. There's a 3/4 of an inch hole that things get through. So what that does is supposed to remove all the trash. And our bar screens are old, so the trash comes on through. So we deal with that trash throughout the whole process of the plant. So a new bar screen would take that out there, and so you never deal with it at a later process where it's not supposed to be.
But I can imagine that a bar screen would be expensive.
Yes, some of the estimates, we're looking around $20 to $30 million, depending on what design you end up with. Is a new bar screen and headworks system is anywhere from $20 to $30 million.
So what is the next complication you have?
So after the headworks, one of the next major issues that we have is an inefficient aeration basin. So basically what that does is after it leaves the settling of the primary part of the plant, a conventional activated sludge plant has microorganisms inside an aeration basin that polishes and cleans the final sewage into about a 95 to 98% removal. Our system is a coarse air aeration system, which you waste a lot of air and to the atmosphere, and less is getting in the process. So a fine bubble system is it's like an aerator in your fish tank. Fine bubbles dissolve into the water a lot easier than just putting your tube down into the fish tank. So the efficiency is moving to a more efficient system. With that, you also get a different type of blower that puts air to that system. Our blowers now are very large, and they run off 4160 power, which is very difficult to work on. We spend roughly around $40,000 to $50,000 a month in our power bill here, and that's the most of what our power bill goes to. So after the sewage leaves the aeration basin, it goes to the final clarifiers. In this system, it has a vacuum system that pulls the settled sludge off the bottom and skims the top. The issues we're having there is it's an aluminum system, and it runs on a vacuum. So the sludge over the years has started eating away the inside of the tubes, and we're seeing little pit holes in the tubes. And with a vacuum system, once you have holes, then you have to, it never vacuums the way it should. The sludge generated from the secondary process from the clarifiers and then from the primary system is mixed together, and we bring that into an antiquated press operation. So when we bring that in, the object is to squeeze the water, as much water as we get out of that as we can, and then we load that into a truck and then take that to a landfill where we pay by the ton. So right now we're roughly getting around 20% solid. So 80% of what we send to the landfill is leftover moisture or water from the system. So we're paying for that water. So we process around and send to the landfill roughly 60 to 80 tons a day.
A day?
Yes. And so that adds up when 80% of what you're sending is water. So we're roughly close to $1 million a year in our annual cost of landfill costs to dispose of the sludge.
Thanks for having us today, Scott. It was very informative.
You're welcome. Thanks for coming down and seeing the plant.